Good afternoon, dear conference participants. The aim of the work was to investigate and analyze the quality of the material. The paper proposes an approach to simulation modeling of the inhomogeneity of composite material of shell structure based on the conductometric method. The object of research is the control of the inhomogeneity of composite material used for the shell structure of mirror antennas by the conductometric method. The information and measuring system for determining the inhomogeneity of composite material by the conductometric method is presented. Typical design of devices for measuring the inhomogeneity of composite material by the conductometric method are analyzed. The shell structure of mirror antennas, mirror reflector or aperture array is used as a control object. For the actuators that ensure the operation of the system, a structural calculation and a description of the operating principle are given. A Petri net is presented to display the process of verification for the presence of composite inclusion and the probabilistic distribution of the time spent by the test material at the working position P1, P2, P3, P4. The state of the working position of the measuring unit during the control process and the computer program and result of visualization of the internal structure of the composite are presented. The error of the measuring channels are analyzed and the mm, and uh, uh, the state of the working position of the measuring unit during the control process and the computer program and result of visualization of the internal structure of composite are presented. The error of measuring channel are analyzed and the permissible values of parameters and operating model are selected. Assumption about the development of the object of study in the search for optimal design, characteristic of the device for analyzing and calculating the measurements and study uh, uh, of the radio engineering characteristic of mirror antennas in the mirror standard wave coefficient, gain and radiation pattern as a constant frequency range are predicted. The development of measuring equipment aimed and providing solution to the problem of automatic the control of various technological testing resort to diagnostic ETS is accompanied by a rapid growth in the variety of types measurements with a steady expansion of measurement ranges and increase in speed and accuracy. The main prerequisite for expanding and the functionality and a fundamental feature of modern measuring equipment is the introduction of a programmable computing power into the measuring chain, mainly in the form of a microprocessor device or computer. The transition from digital measuring instruments and device to processor-based measuring instruments has led to the fact that the measuring device has two parts, hardware and software. Since a significant part of the measuring procedure is realized in digital form. By means of measuring transformation of digital arrays, measuring transducer as measuring instruments designed to convert physical quantities into output signal convenient for measurement or further transformation are becoming increasingly used both in measuring equipment and its automatically process control system. Manufacturing and calculation of mirror antennas on the initiative and direct participation of Professor Oleg Shabli and Associate Professor Andrei Rudnik began at Ivan Polytechnical University and continues to this day with the search for technology for forming surface with specific geometric properties and increase accuracy of the shape of the reflective surface. In particular, as one of the options, the method of forming a reflective surface of a given profile by electric arc spraying was considered. It was supposed to manufacture a reflective surface from a mesh material blank placed on punch by applying an electric arc spraying coating on it, which would reduce the overall dimensions of the shell in terms of thickness and weight. It should be noted that in order to maintain uniform application, it's important to correctly position the working unit in relation to the punch surface to move its constant distance and orient it normally to each point on the surface. And now on this page, we can see a reflector in the form of paraboloid of rotation and a parabolic cylinder. Formation of shell by electric arc spraying and application of composite material, the formation of mirror antennas, aperture arrays consist of several stages. The first stage is the formation of the two-dimensional mesh and fixing of the nodes by electric arc spraying with aluminum. The second stage after sputtering on the punch is to obtain a surface with a high temperature and apply a composite material such as polystyrene. Polystyrene is a polymeric material used in the manufacture of various products due to its unique properties. Patronets are structure defined by a set of input and output transactions. Modeling system using patronets. Simply patronets contained only three basic elements: nodes, transition, and markers. Therefore, building models of complex dynamic system with a large number of interacting parallel and asynchronous process and many information and material flow become a rather complicated and cumbersome procedure. This significantly narrows the class of system models that can be built on the basis of simple patronets. In such cases, extensions of simple patronets are used, which make it possible to significantly simplify the construction of complex model and their graphical representation, expanding the capabilities of nodes during modeling. Further expansion of the capabilities of patronets for modeling tasks associated with the transition from the use of nodes with marker and transition to the use of data warehouse, a node with a certain data structure and data streams. The transition triggering time can be fixed or calculated. It depends on the time scale used in the model and the time tick that the model developer determines. The simulation time is advanced with some fixed value of the time tick, for example, every second. Time rounding errors do not affect accuracy if the simulation time is specified as an integer data type. The deterministic value of the triggering time can be directly assigned to the transition attribute, while the arbitrary value of the time must be determined, or rather calculated. During the modeling process science, it may depend on the value of the marker. Thus, a new arbitrary time value for the transition is set for each bit of the model time, just for the triggering of the transition. And we can see a patternnet for displaying the process of checking for composite inclusions. On this page, we can see a probabilistic distribution for the time spent by the test material on the working position P1, P2, P3, P4. And the next figure, its status of the working position of the measuring unit during the control process. The conduct simulation modeling of the digitized data set on the composite structure and MATLAB program code was developed and for random sample. T1, T2, T3, and T4 of size N10. Each were generated using a normal distribution with different parameters, mi and d, for each sample. The probability density of the distribution is then calculated for each sample using the norm PDF function to display a distribution density plot. Using subplot to subplot creates four plot windows, each plotting the density of the distribution for the corresponding sample. Each plot is located on the corresponding row of the subplot grid with the subplot arguments indicating the row number, the number of rows in the grid, and the number of subplots per row. The results of the measurement data are digitized and visualized in the information block for either interpretation. A digitized data set on the structure of a composite may contain information on various parameters that characterize its internal structure. And we can see a monochrome representation, a color presentation, and a refractive presentation. The digitized data can be presented in the form of table where each row corresponds to a specific computed sample, and the columns represent various parameter characteristic structure. This allows for further analysis and modeling of the composite structure to visualize the measurement data. The information block uses a graphical interpretation in the form of a color map, and a function with an offset of 40 is used to construct a contour plot. It should be noted that the conductive cathode is located in the center of the material, and the anodes are usually somewhat spaced along the edge of the mirror. The resulting graphical representation in the figure above allows us to draw conclusions about the structure of the composite material. We can say that the material is suitable for use without negative inclusions and surface crack of its higher quality in the center and closer to the edge. It has heaven non-conductive inclusions. The significant result obtained is a simulation of the heterogeneity of composite material of shell structure using the conductometric method as the basis for their use in instrumentation and radio engineering and cyber-physical biosensor system. As an example for the rapid and reliable transmission of information and data to specialized clinics or the results of assessment and prediction of medical indicators of human health, which is especially relevant for the transmission or data and diagnostic information in telemedicine system or other system. Thank you for your attention.